Let's talk about a critical part of every X-ray machine you've ever seen, the anode.
Let's start with a wild number. In X-ray production, 99% of all energy is just waste heat.
So that massive heat is the biggest problem to solve, right? So how do we do it?
Well, the anode's job is to be the target. Electrons slam into it, and boom, X-rays are made.
The first and, simplest answer to that heat problem was the stationary anode.
It's a pretty simple design, a tungsten target stuck inside a big copper block that soaks up heat.
And its strength is its simplicity. No moving parts means it's super reliable and nice and small.
But there's a big catch. Hitting one tiny spot with all that energy creates a major heat problem.
So, to get past that limit, engineers had a brilliant idea. What if the target actually moved?
And that brings us to the rotating anode. Here, the target is a disk that just spins like crazy. So instead of hitting one spot, the beam hits a whole circular track, spreading that heat way out.
This brilliant design gives it up to 1,000 times more surface area for cooling. Just incredible.
So what does all that cooling actually get you? Let's look at the real-world performance numbers.
A stationary anode? It tops out around 15 milliamps. Rotating ones can handle over 1,000.
And that massive power gap, it changes everything. It dictates what you can use them for.
So, on one hand, stationary anodes are simple and reliable. On the other, rotating anodes have way more power.
And that performance difference? It tells you exactly where you'll find each one in a hospital.
You're going to find stationary anodes in things like portable dental units where simplicity is everything.
But for the really demanding stuff, like CT scans, only a high-powered rotating anode can handle it.
So, what's the bottom line? It's all about choosing the right tool for the right job.
Yeah, it's that classic engineering trade-off. Do you want simple and cheap, or pure power and capability?
And innovations keep pushing these limits, which really makes you wonder what's coming next for X-ray power.